All right. So, finally, for today, we are back with the final speaker. So, Kevin, your Kate Preet is going to be talking to us about no STD. We were talking the other day about what would be cool to go over, and Kate Preet mentioned this, and I am super excited because I don't know a ton about no STD, and so Kevin, I'll let you take it away. Oh, I think you're muted there.
Thank you. So this talk was actually inspired by what I've been doing recently due to having acquired my pre-order of the Panic Playdate, which is a tiny little, oddball games console. The big feature being it has a crank on it. So I'm always a sucker for weird input devices. So I said, well, can I port my game to it? And this being well, it's not no operating system; it's a weird operating system. So and it's got this 1-bit LCD that reflective. So people like to compare it to the Game Boy. But anyway, so that project did not go out well because well, problems not yet debugged is that it's the only error message I get is a stack overflow, which I'm not sure that's actually accurate. So, but I did a lot of preliminary work, and I'm going to tell you about why this might be an interesting thing to do, even if you are not planning to port your game to a weird console. Right. So, the first question I want to is, what does no standard mean? It means writing code without some of Rust's standard library. Not all, some. Because, let's see. And so it's not as restrictive as you might think. Now, why would you care about this? Like, isn't no standard for, embedded folks? Well, the one basic reason is simply increased platform compatibility. It means that, as I just mentioned, you can port your game to consoles, to weird platforms, to retro platforms. Rust will go all the way down to 16-bit processors, and maybe you're just interested in running your game on the web, and it turns out that the current state of Rust WASM is kind of weird. It has the standard library, has some of the standard library. So if you can just skip all of that part, then you won't run into problems. Or you can be interested in it for the sake of loose coupling. If you use no standard in one of your crates, then that means that you can know that is not doing any IO. It is only doing computation. And that is a constraint which can be useful for structuring your program so that it is more testable, more adaptable to, again, different platforms. And it can, it's an architectural constraint which can be useful. And finally, if you have something that is a library that could be used elsewhere, then I encourage you to make that library, no standard compatible, because it will, it means that it will run everywhere. Well, there's a couple of asterisks on that everywhere. But, and, even if you haven't written a library, are you sure sorry, wrong points. So this discussion is mainly about libraries, because in the end, your binary, or if you're for some reason compiling your code into a dynamic library, it's going to interact with the environment somehow. So we're talking about the subset of the code which can just interact with other Rust code. I've always found this is just a library to be a very useful constraint to enforce, because it nails down which things are going to interact with the rest of the world versus everything else. So, and if you don't have a library, are you sure you don't have a library? There are lots of cases where you end up with a module of your system that it could be a library. And now you shouldn't necessarily do this all the time, because creating a separate library is a constraint that will it will give you more maintenance work, but than not doing that. But Well, sometimes we want to, sometimes we like the idea for whatever reason or another. So I'm not telling you you should do this. I'm saying that if you have a library, consider making it no standard. So let's talk about how to actually do this. The easy parts of this are most of what you want from the standard library is just in core. That is, so the Rust standard library is broken into 3 Rust crates. Those crates are called core, Alloc, and standard. Standard re-exports all the stuff from all the other crates. So if you are only familiar with standard, that's because it includes the rest. So the first step on the path to no standard is just change your imports, change your use, so that it says use core instead of use standard. And there's lots of things that you can do this with. There's like your basic types, like your string slice, your numbers, this traits like iterator and debug, all of those things are in core. Again, there's even stuff that is suitable for interior mutability stuff like cell and ref cell, and even atomics. You think about atomics as being thread safety things, but they're in core. Again, even future is in core. You can write asynchronous programs, as long as you skip the executor part. Then we can, now that's the part, that's all the stuff that is in core is the stuff that works even if you do not have an allocator. But in most cases, you're going to have problems that are complex enough that you want an allocator, and that's what the Alloc crate is for. It contains interfaces for the allocator, and it contains the types which require an allocator. So so we have string, we have box, of course, we have vec, we have cow because it has the own version. Formatting to string is in Alloc because it requires it. Has btree map, so. The annoying part here is that hash map is not in Alloc, but you can use btree map, or we'll get to other options later. And you can even have reference counting in Alloc. So there's a lot of stuff that you can do that you might have thought that you can't do just with no standard. And finally, you can ask Clippy to help you perform this migration. There's these 2 links which will tell you whenever you have an import that could be written with core or could be written with Alloc. Now, right now, Clippy will not automatically fix these for you, but a change for that is coming up in the upcoming Rust release. I actually asked for it and somebody implemented it. Yay for open source. So next we have the less easy parts. So you do not get to spawn threads, because spawning threads is about talking to the operating system, and that's in standard, and it's not in core, it's not in Alloc. But if you can rephrase your problem, then you may be able to do so to make things convenient anyway. So one obvious answer is you can write async functions and provide them to the user of your library, and just let the user of the library set up to run those async functions concurrently. So async is a great, and sometimes you don't even need threads. Sometimes you just want to do 2 things, and async combinators allow you to do things concurrently but not in parallel. That is multitasking on a single processor. And in fact, if you actually want to run on embedded platforms, like this here is a single core device, so you have to use and the operating system doesn't give you threads, so you have to use cooperative multitasking. Lots of great software has been written that way. Don't knock it. Or you can try to express your problem in iterators. Do it the way the functional folks like. Try, and then if your problem is shaped like that, then you can say that you can do things like, if the standard library is available, then you can also use Rayon for parallel iterators. So again, another approach to getting at parallelism without necessarily baking it into your system. Though Rayon does not have it. Rayon is not itself no standard compatible, so it's something you have to do a bunch of work to optionally use. And finally, there is the most simple option, which is to just say, your library provides algorithms and doesn't care about scheduling, and it's the caller's responsibility. It's the dependent's responsibility to use your algorithms. That's maximally flexible, but it means that it can mean that you're exposing more of your structure to your caller. And that's always a constraint to think about, because it means that, what can you change in the future without breaking the API? Of course, if you're writing a library for internal use, then you don't care about breaking your API. That's a perfectly fine thing to do. But if you want to publish your own, okay. Another problem is you will be missing some floating point functions. If you're writing a game, you've probably got some uses for sine and cosine, and you'll find that those methods are missing. The answer, however, you can simply use libm, libm is just a Rust crate which implements these algorithms for transcendental functions and all that, without using any non-Rust code like the standard library does. And furthermore, here's an interesting trick. So numtraits library contains traits that are used for being generic over numeric stuff, but the numtraits float trait, actually you want float core as it's called. Is that right? No, sorry, I don't think that's right. But anyway, you can use numtrait. You can import the numtraits float trait and get back, and as long as you've enabled the libm feature, you can get back all of those floating point functions with exactly the same interface. So if you just conditionally import that, then you can use either standard library or you can use, local re-implementation of it. And so that's not really a problem at all. It's just one of those things that they have to do. Another annoying part is hash map. So the standard library does not include, so the standard crate includes hash map, but Alloc does not. And this is for the slightly annoying reason that the standard library hash map uses randomness to randomize its hash functions, which is great for designable service protection, but it means that hash map isn't present in Alloc. And it would be nice if a hash map was present in Alloc because you can just swap out the hasher, but for architectural reasons that isn't actually happening. So for now, your choices are: one, you can use the hashbrown library, which you may have heard of as this is the hashing implementation the standard library uses, and that's actually true. But if you use hashbrown directly, then you get to use it without that system dependency, and you'll get exactly the same interface. Of course, the problem is if you want to have a hash map in your library's public API, well, now you have a problem. But usually you don't actually have to do that. And finally, you can also use btree map. Btree map is, again, it's a map. It has basically the same interface as hash map, except that it uses sorting instead of hashing. So your key type has to implement ORD as opposed to your key type has to implement hash. And this can actually be useful for game development because btree map is deterministic. It always presents its keys in sorted order. And it also you can also query it by ranges. So you can say, give me the keys, from here to there. And so it can be useful for some other purposes. So, take a look at it. Now, the reason that we don't use btree map by default is that it can be less efficient than hash maps because it requires traversing a tree, which is more in directions, more pointer lookups than a hash map by default. But again, if you care about the performance, benchmark it and see what you get. And a small btree map doesn't have very many levels, so it can be fine. It's just not constant time like a hash map is. The next thing that you might miss out on is atomics. Now, so if you've ever written code that generates 64-bit global counters, then you may find that this platform does not support 64-bit atomics, so you can't assign those unique IDs. So you might have to change something and say, okay, well 32 bits will do, and we'll check it for overflow or something. But there are parts that potentially could give you a lot of trouble. So think of this part of the talk as the list of things that you may want that may put you off doing this entirely. Send and sync. In Rust we love our thread safety, but if you do no standard, you have you lose several things from the standard sync module, such as mutex, RWLock, all those things, and MPSC, all those things that just let you have inter-thread communication or sharing that works. Now remember, ARC is available, so you don't have to give up sharing things between threads. You only have to give up the synchronization parts. So this is trouble if you want inter-immutable objects that are thread safe, but maybe you don't need any interior mutability. That's, it's always a good thing to not, you keep that to a minimum, but sometimes there are problems where that's the best solution. So, finally, if you have callbacks, and those callbacks are like, box dine, some trait object, then you have a problem, because when you use trait object, you have to specify, is this send and sync, or is this not send and sync? And so there's a catch here. So a lot of this problem can be you can solve this by saying, okay, my library is going to have a feature, and it's going to either use the standard library, or it's going to not offer send and sync, and you can do that. The catch is, if you're accepting a callback, you can't make if you make that conditional, now you've done what we call a non-additive feature, which is to say that if you have two dependents on your library, one of them activates the feature, and one of them is expecting to be able to pass a non-sync callback, then the one stops the other from compiling. So you really want to think carefully about, what do you want to do in this situation if it comes up. But of course, a lot of code doesn't need any of those callbacks. And if your callback is generic, if it says, if it's, generic over F, which implements function and so on, then you don't have to worry about this, because the, auto trait leakage will means that, the compiler will just accept the things that are valid and reject the things that aren't. You don't have to choose one or the other. Let's see, another catch is if you have any kind of global lazy initialization or global caching, those generally depend on mutex or something like mutex, and those are also not available. So if you want no standard, then you have to leave those out of your library. Again, you can think about this as, let the caller have choice of what policy to enforce. On the other hand, there are things where it's clearly just lazy initialization. Well, maybe you can initialize that at compile time. Const stuff is can be pretty powerful. So things to think about. I saw a question. Somebody asked, can you use thread locals? And the answer, as I understand it, is no. Or again, you can. There may be a way to have thread locals if there are even threads, but it will be platform specific, because that's what you're giving up with no standard. You're giving up all the things that involve talking to the platform, and so thread locals are one of the things that you can't do. Right. Let's see. Okay. Another annoying thing: the error trait is in standard, it is not in core. This is widely regarded to be a mistake, but it hasn't been fixed yet. There's work in that, but for now, if you were defining error types, you have to skip the error trait. Now, this isn't as terrible as it sounds, because the error trait doesn't actually do much itself. Most of what being an error means is the error trait says this has to implement debug and this has to implement display, and you can do that separately. And if you're using the this error macro, take a look at display doc instead. It does basically the same thing. But if you have chained errors, the source method, then you're going to have to give that up. And this might be fine because in the cases where somebody actually wants to not use the standard library, then they're probably customizing their error handling anyway, because exit to desktop is often not an option in those kinds of situations. So it may be fine, but it's another thing that you have to deal with. And someday we probably won't have to. Let's see. Another hazard is dependencies of your code that could be no standard but aren't. Because one of the reasons I'm giving this talk is a lot of people don't even think about no standard support, but so maybe you can just send them a patch and take care of it, or maybe it'll be more troublesome. You might have to find some other libraries, or you might give up. And again, maybe you don't actually want to go through all this bother. Maybe you really don't want to abstract away all of your IO from your main code. And I'm sure everyone knows about, you've written a game processing, you felt the urge to, combine your rendering and your game logic, even because it's very extremely convenient and efficient, even though they're logically separated concepts. So that kind of thing can push towards, well, don't introduce these abstraction layers, don't make a mess. And even getting the current time is an I/O operation. It's going out to some hardware that's mediated by the operating system to say, tell me what time it is. So you don't have system time, you don't have instant. And so if you're doing self-profiling, that could be really annoying. So I went ahead and gone and abstracted it, and it went pretty well. But again, it's one of those things that's kind of bothersome. So you may not want to do this, or maybe this sounds like a fun challenge and you're going to do it anyway. So let's get to how to make it happen. So I've looked over a bunch of different ways to do this, and this is my opinion on how best you should do it. So if your crate simply has no unit tests, we'll get to why testing is important in a moment. Then you can do the most brute force thing is just saying, okay, we declare no standard, which means your crate doesn't implicitly link to standard, and it means it doesn't implicitly import the standard prelude. It imports the core prelude instead, which has fewer things in it, like it doesn't have string in it, for example. And then you usually want to say to declare Alloc, because you want to be able to access Alloc. Now, the reason that you have to say extern crate here is because, well, once upon a time, you had to declare extern crate for all your dependencies. The reason you have to do it here is because these dependencies are not managed by Cargo. That might change in the future, but for now, they're not managed for Cargo. Cargo does nothing about whether or not your crate is linking to the standard library. So if you want to use one of the unusual crates here, which Alloc is basically the only one we care about here, then you have to declare it explicitly. So think of this as what you do here instead of adding a link to your dependencies list. Now, if your crate has tests, those tests probably depend on the standard library. Even if they do, even if they don't necessarily, you probably want to use things like vec and so on for collecting data and then comparing it with some asserting about it and so on. So we want to change this a little bit. We want to say, if we are not compiling tests, then this is a no standard library crate. So a small complication. And when you compile for your tests of your library, Cargo will still compile the library itself, without the test configuration set. So you still get testing that your crate compiles with no standard. This is just when compiling the tests themselves, you will be able to use all of the usual standard features. And you could skip this, but I recommend doing it because it's a lot less annoying than otherwise. You don't really want to have to be writing lots of imports in every test module you have. However, there are a lot of ways that you can complicate these things and make it so that you have more mess of imports than you could really need. So here's the common things that I've seen that I recommend that you don't do. Do not, if your library has a use the standard library feature, as many Rust libraries do not make your no standard conditional on that feature. It's the reason is now you're changing what the prelude is. You're changing what's in scope based on this condition, and that makes your code more fragile. Instead, just extern crate standard. That do that conditionally. That makes everything much more regular. And don't conditionally change which things you're importing from where. If something is in core and in standard, you can import it from core even if you're using standard. You do not have to make things conditional. You do not have to rename one Alloc as standard or something like that in order to make things compatible. Don't do this, because then you will be surprised by, oh, this entry doesn't actually exist. You can always use the core crate. You can always use the Alloc crate under all conditions. You do not have to avoid them if you are using a standard. So that's how you declare it up front. Now, but here's the question. You have existing code. How do you migrate it? Here's a plan. First of all, go through your dependencies. Disable those default enabled standard features. You will find a lot of them. You will find that you don't actually use a lot of them. So just go audit your dependencies, go through them and turn them off. And this is a great way to notice if there's any dependencies that will be more troublesome. Then add those links I mentioned, which will tell you if your imports are unnecessarily using standard, and fix them. Then you will probably find that you have some dependencies which, unconditionally depend on the standard library. I myself was using a vector math library which unconditionally depended on the standard library, so I had to change to a different one. That was super annoying, but maybe you won't be in that position. You will, but this is a great way of thinking about, do you really need that dependency? And sometimes the answer will be yes. Again, this is a point at which you may say this is not for you, but what you want to do is you'll remove these dependencies and you'll work towards the question is, does your no standard build succeed? I'll talk more about that in the future. But the first thing that will fail here is your dependencies won't compile. So so fix those first. Now, this is optional. I think it's probably a good idea for your migration work, but introduce a feature into your library which says, do you want to try to use the standard library? The idea here is this gives you a way to have your code continue to build and work normally while you work on making it succeed at compiling without that feature enabled. Now, you don't necessarily want to call that feature standard because that's a statement about what you're depending on, not a statement about what are you offering to your dependents. So maybe what you offer under this condition is thread safety, and so you should call this feature sync or whatever else apply, or maybe you should call it threads, or just so think about what you're providing, not what you're implementing. Then work towards getting the crate to build with that feature disabled. And this is the point at which, again, this you may find that okay, this is not going to work, we give up. But if it do, use this feature to be able to incrementally work towards it rather than having to do it in one giant commit, because that, or breaking your build, because those are also both terrible ideas for development speed. Then the next step after building in the actual no standard condition is get the crate to build without on a compilation target, on a cross compile it to something that doesn't have the standard library. There's a number of embedded targets that you can use for this, and REST-up can install that for you. So this doesn't require any complexity of your build. It's just another build command. You just see if that works, and you probably will find more things to fix here. Now, finally, you have a build that works, and maybe you've even tested it. Now, if that feature you added is not actually providing any value, if it doesn't turn on anything that you care about, then just delete it, because the best possible library is one that that you don't have to configure, that it just works under all conditions. So you may find that your library does not ever need the standard library, or you find that there's reasons to pick. Whoa. Sorry. Okay, now let's talk about testing this stuff. So remember, just declaring no standard doesn't mean your crate won't attempt to link the standard library. It doesn't mean your dependencies won't attempt to link the standard library, because nothing's actually checking that except the linker. So you need to build. Check your build. Use a target that doesn't have the standard library and therefore is guaranteed to fail if you use standard. So the command, so you usually, so you'll run your cargo check, and it will have, you'll have no default features. So probably assuming, because if you have a feature, you don't need to, if you don't have a feature that, and you don't ever depend on the standard library in that, but just specify a compilation target which doesn't have the standard library. This is an example one. This is the target that you use if you were compiling for the playdate. And it's very common for, modern embedded systems to be using, this is a flavor of ARM basically. And, so it might be something like that, or it might be some v6 or whatever, but just pick one of them and continue with them. Though there are some reasons that you might want to pick a specific one. So if you're wondering why is one of your dependencies depending on the standard library, then, and this is a very common problem because these dependencies can be pretty tricky. What you want to do is use the cargo tree command, which prints out a tree of dependencies. So, and then you want to customize which edges of the dependency graph it's showing. You say features, which means don't just show which crate depends on which other crate, show which features are being enabled, because you want to spot those standard features that you wanted disabled. Fine. Also specify normal. Now, normal means just plain normal dependencies. In particular, it doesn't include build dependencies and it doesn't include testing dependencies. So by specifying this explicitly, you actually hide all the build dependencies, which you don't care about for this purpose, because builds, of course, always happen on the host, and hosts, the platform that's actually running the compiler. So that you can use. So this will be a very handy tool to use while you're getting started. Of course, after you got you've got your build working, you don't need to worry about it too much. Okay, and that is everything. Now, let me just review what anybody has asked about. And John Farrow was saying, why are these in core instead? Wouldn't it make more sense to just always use things from core? And yeah, that's basically the point of my talk. Yes, you can always use core. And if you're wondering about why Rust didn't do that way from the start, well, there's an interesting story there, and that is Rust was not originally envisioned for embedded development. Rust originally did not have this three-crate split of core, Alloc, and standard. It was originally just standard. That's actually why the WASM32 unknown target is weird and has a half-broken standard. It was invented before core was. So if you want to write your code style so that you always use core when core is applicable, perfectly fine to do that. In fact, that's almost what I'm encouraging you to do here. But it's the reason it's not part of standard Rust code style is because it wasn't where we started. And of course, it's annoying to have to think about exactly what's in where, because, like, for example, if you've written standard sync arc mutex, because you have mutexes in arcs, then those, if you wanted to stick to the strict style, you'd have to say use Alloc sync arc, use standard sync mutex. So that's kind of annoyingly verbose. So reasons not to do that. I see a question asking about the playdate. Let's see. So is it useful for other stuff apart from games? Can you connect a sensor? So the playdate does not have very much input and output. It has its buttons, it has its crank, it has a microphone, it has headphone output, a speaker, and it has an accelerometer. No gyroscope, no GPS. It has Wi-Fi and Bluetooth, but the Bluetooth support is still being worked on. So I would not recommend the Playdate as an embedded starter platform unless you're trying to well, it's not. I don't think it's a great way used for as a battery powered shock sensor. There's better equipment for that. And there's better uses for this. I'd say the great thing about it is think about it as Gamedev under constraints. So this is a black and white screen, and it's very high resolution, but it's black and white. So you get to have fun with dithering, but it is high resolution. This is like twice the resolution of your classic Game Boy. So But if you try to target this, the lesson that I learned to write is, yes, remember, there is not much processor on here. It's a 200 megahertz or something like that, single core. So, which is a lot compared to once upon a time. But, what I'm talking about here is this is you can do, I'm encouraging you to do this when it is easy. Actual embedded development is doing this, or small system development is, doing this when it's hard. So, pick your challenges. Okay. I think I see another question coming up.
So I have a question that I was typing up, but I think I can just sort of ask instead. And so what it sounds like to me is that no STD focuses a lot on not making any presumptions about the hardware it's on.
Yeah.
Not focus anything like that. So once you have, say, like that base layer, what does it look like to go a level above? Like, let's say, for example, you're writing something for the playdate and you wanted to add functionality for, I don't know, like the buttons or the sensors, or like maybe like the CPU that it has.
Well, so okay, there's two different activities here. Like one of them is like writing bindings, okay, and that's basically just like you would do if you wanted to use a C library. You would you look at the API, you take your header files and run them through bindgen or something, and you write some amount of adapter code that makes it more rusty to use. It's like put all the unsafe behind safe interfaces. So fundamentally, adding operating system interfaces or hardware interfaces isn't that much different from foreign function FFI code, C library code. It's the same problem fundamentally. It just has different flavor. But I'm not very familiar with the actual practice of doing that, so I can't say much. I just say it's not a hard problem. It's an annoying one, and it's one where you're going to have to probably have to debug some crashes and so on. So the thing I'm focusing on here is supposing that you have your bindings already, how are you going to get your code to work to compile under these conditions? And if you take the approach that I'm talking about here, which is where you write a pure Rust library that's also no standard, then this is about writing the part of the code that doesn't care about the platform. And this may mean that you have to define define functions or traits or something that is this is a gap to be filled with the platform interface. And so it's useful to know what the platforms you're targeting are like in order to design that interface, because if you don't know, you may find that you design it wrong. The classic things like oh no, the function takes a callback, but the callback can't return an error. You've been in that situation, or this can't be async. So you want to think about those things. So actually, I'll mention that. One of the reasons that I mentioned that one of the reasons you might want to do this is like to follow the to follow the sans.io paradigm. And so what this is the idea that your code should not contain any the classic case where you'd want to do something like this is, for example, a network protocol implementation. If you're implementing a network protocol, it's often useful to not to just express it in terms of parsing and generating, and avoid actually doing the socket calls, because this means that then, for example, for a Rust specific example, then that you can have that code can then be used either synchronous or asynchronous, or or for example, if you avoid the standard library networking interfaces, then that means that it can also be used on embedded, because the embedded doesn't have a standard library, probably has a weird sort of TCP stack or something, if it even has one, or maybe you want to actually communicate over Bluetooth instead. So there's lots of reasons to separate your algorithms from the way they interact with the outside world. And so I forget where we got here from. But what I was saying is that doing this separation is a good place to start if you want to do embedded development, because it means that if you have this separation, it means that you can test your code on your host with all of your debugging tools, all of your testing tools, rather than being stuck at like it says, I have a crash report here. It says Stack Overflow. Okay, that's all the information I have. Not helpful. So
yeah.
So it's always good. So it's always good to make your code portable between where you care about and your best dev environment.
Mm-hmm. I think these are some really good points, and I really like how sort of you've broken it down into separating out where this sort of entire talk sits, or like where no STD sits, because in my mind I haven't really done no STD before. It very much in my brain is like, why would I want to use no STD? I want to have a programming language to use. But then what it's actually like is you use no STD and you have a lot of stuff from the programming language still. I mean, pretty much everything. There's some things that you don't have. But it's also very similar to how we see, I think, unsafe. A lot of people look at it and say, why would I use unsafe? I want Rust to be a safe thing. And it's like, no. There's a few things that you get access to and a few things that change. It's not, you don't lose the language.
That, of course, that perspective, there is something you said about that perspective. Like, I think it's a good place to start because, a lot of people that do write unsafe, like, writing unsafe requires a very certain kind of careful thinking about the problem. And I think it is correct for most people to say, okay, I'm going to avoid that. Now, that's not the same thing as using libraries which contain unsafe, but I think that absolutely you should, skip unsafe until you have it. But why I want to emphasize about this, this concept of choosing to use no standard is it's kind of like it's in the opposite direction of using unsafe. Using unsafe is depending on more platform details, often, and it's it's a thing that you have to maintain harder. Whereas no standard code is writing no standard code that isn't platform specific is about saying I depend on fewer things. Fewer things have to be true for my code to work. Now, and again, like, I'm a big fan of writing an abstraction even when it's not strictly necessary. So I tend to write libraries because that modularity, to me, that helps me say, okay, I have solved this problem and tucked it away in this box. Now I don't have to think about it as much. But on the other hand, too much modularity can mean that you're standing on top of a teetering tower of abstractions and you're not actually getting your game written.
Yes,
so
that's so true.
So don't let this stand in the way of writing your game by saying, if you find yourself having a library, if you're going to publish it anyway, and do give that a thought, let people reuse your work, then consider making that library no standard.
Yeah. One thing that just came up in chat that I think is a pretty good way of thinking about it. I think the idea is to move the dependency on STD and hence the platform as far up the dependency tree as possible.
Yep, that's a good way of looking at it.
I think I might have lost your video a little bit there, or maybe it's on my end. It could be on my end. Wait, is it my end? One sec. Let me check the live footage here. Oh my gosh, I'm gone. Oh, wait, am I back? Can you hear me?
Sounds good to me, but
okay. I think I got. I don't know. Somebody froze for a second. Okay. Yeah, I think that's it for questions. Is there anything else you want to cover before we call it?
Nope, I think we've got it all.
Perfect. Well, thank you so much for this talk. This was a ton of fun, and like there's like an insane amount that I didn't know, and so this was like a really good view into why you might want to consider no STD, and also some of the constraints that you'd come across in different platforms. And so, Kevin, thank you so much for this talk, and I hope that we can get you back in a future month to talk about some other cool stuff that you're working on.
Well, I mean, hopefully someday somebody will see stuff running on this, and if not, I'll probably have something else.
Perfect. Well, I'm definitely very excited to see it. And so, so that's it for today's Gamedev meetup. And we will see everybody next month.